So the different kinds of reactions, well, there are many, but we are looking at the few that we are going to investigate further in our course. They are combination reaction, decomposition reaction, single replacement reaction, and double replacement reaction. Let's write down the balanced equation for all four, and then it will become clear as to what each one looks like. In a combination reaction, as the name combination suggests, you are combining the reactants. And here, the simplest way of writing it is A, one reactant, B, another second reactant reacting to form one compound product. The joining of two or more elements or compounds producing a product of different composition. In a combination reaction, you can have more than two reactants, but in the simplest version, you have at least two reactants combining, and the number of products must equal to 1. That's the requirement. You could have 3 reactants, 4 reactants, 5 reactants reacting to produce one compound, one final product. Here are two examples: sodium and chlorine reacting, sodium metal plus chlorine gas reacting to produce 2 NaCl solid, magnesium oxide a compound, and carbon dioxide another compound reacting to form magnesium carbonate. In the first case here, you have two elements. Chlorine is in its elemental diatomic form, sodium is a pure element, but in this other example you have two compounds. So you could mix elements or compounds, either all elements or compounds, or either a mixture of elements and compounds as well. And when they react, they form chemical bonds. They don't just mix into each other, they combine. So this is an example of a combination reaction. Combination of a metal and a non-metal to form a salt is one example. Combination of hydrogen and chlorine molecule to produce hydrogen chloride. Okay. Combination of formation of water by combination of hydrogen and oxygen, and magnesium oxide reacting with carbon dioxide to form magnesium carbonate, which we saw here in the last one. Those are some examples. Decomposition is the reverse of combination. In a decomposition reaction, what you have is just one reactant now, breaking up into many products. Here in the most simplest form, it breaks up into two products, A and B, but it could break into 2, 3, 4, 5, 6, any number of products. So we saw that decomposition reaction with mercury oxide breaking up into liquid mercury and oxygen gas. Calcium carbonate can break up into calcium oxide and carbon dioxide. That's another example. Yep. So when you heat calcium carbonate, it will break up into calcium oxide and carbon dioxide. Also, when we talked about that those hydrated compounds previously, such as copper sulfate, and if we go back to the slide where we had copper sulfate, where is that? Here it is. This is the hydrated copper sulfate. When it is heated, it decomposes, or rather it breaks up into two, copper sulfate and water. So that this reaction, if it carried out by heating it, would be an example of a decomposition as well. Then we have a single replacement reaction. What happens is you have this form where one of it is a compound in the form of B and C. It's mostly an ionic compound, but could be equivalent as well, such as AgNO3, where Ag represents B and NO3, the polyatomic anion nitrate, represents C. Copper here is a pure element. It comes and replaces one of these two. It will replace B here because B is a metal and it itself is a metal, so it will replace other metal. So instead of having silver nitrate, what we have here is copper nitrate. Here you have sodium and water. You can write down water as H bonded with OH, where you have a hydrogen and a hydroxide, a proton H plus and a hydroxide OH minus. Well, sodium is going to replace that proton H plus, and it's going to take the form NaOH, and the other compound, the other substance that's formed is H2, hydrogen gas, after balancing out the equation. Both of these are balanced, by the way, both of these reactions. So you have 2AgNO3, 2Ag. Look at the formula of copper nitrate. We learned in the last chapter how to write the formulas, right? Silver nitrate, silver has a charge of 1 plus, nitrate has a charge of 1 minus. When you crisscross them, you have AgNO3. But copper in this case has the charge of copper 2 plus. You have to be told that in order to balance it out correctly in this case, because it's one of those with a variable charge, either copper 1 plus or copper 2 plus. Nitrate with a charge of 1 minus, when you crisscross them, you get CuNO3 parenthesis 2. So this is single replacement, and here are two examples: replacement of copper by zinc in copper sulfate, which we saw, replacement of aluminum by sodium in aluminum nitrate. When you see this reaction happen, by the way, you would have copper sulfate, copper metal in the form of either a strip of copper or beads of copper in a solution of silver nitrate. Copper has reddish brown color. Over time, what you would see is that the surface of copper turns less reddish brown, it becomes silverish. That's because the silver from the solution is coating it. Look over here at the symbol S, it means it's a solid. It gets the copper gets coated with silver and it exits the solution. When what happens to that copper which was originally in that place, it enters inside the solution, and copper ions are generally blue in color, so the solution becomes blue. Now the double replacement is when you have two compounds AB and CD and they replace their partners. A goes with B and C goes with B. Notice how it's written, AD plus CB, not DA, because you write the metal first, then the non-metal, or the positive part first, then the negative part. The same with CB. C is the positive part, B is the negative part, so it's CB, not BC. Here is an example: hydrochloric acid, HCl. This is hydrogen chloride, but when you dissolve it in water, it becomes aqueous, AQUEOUS. We write that in parentheses as AQ. Similarly, sodium hydroxide solution, aqueous solution, when you bring them together, they will react with each other and they will replace each other's partners. H will go with OH to form H2O, and Na will go with Cl to form NaCl, a double replacement. Here is another example. In this case, we have salts, lead nitrate, PbNO32, and sodium chloride. Pb goes with Cl forming PbCl2, and Na goes with NO3 to form NaNO3. What we haven't learned about balancing the equations yet, but you should be aware of why the identities of the compounds are the way they are, why the formulas of the compounds are the way they are. So NaCl is NaCl, but then PbCl, well, we don't have PbCl here, we rather have PbCl2. That's because Pb has a charge of 2 plus. If you find out what was the charge on Pb here, before this reaction took place, it was Pb2 plus. So here we preserve that 2 plus, and when we crisscross that, we have PbCl2. Okay, although we have NO3 2, that's only this 2 is coming from Pb. But when it combines with Na, Na has a charge of 1 plus and NO3 1 minus. When you crisscross them, you have NaNO3. So these are the four kinds of reactions. Next, we will learn about balancing chemical equations.